Good morning, everyone. Myself, Devika, working as Assistant Professor in the Department of Electrical and Electronics Engineering at Sri Muthapamma Ministry of Technology. Today, we have learned about the subject on protection switchgear W3601, which is a core subject for 2021 regulation in the Department of Technology. Today, we are going to see the topic on what are the zones of protection in the power system, then what are the methods of working in the power system. Zones of protection. In a power system, the entire network is divided into several protection zones. Each zone is protected independently using relays and circuit breakers. When a fault occurs in one zone, only that particular zone is isolated and the remaining healthy system continues to operate. This helps in maintaining continuity of supply and prevents total system failure. Hmm. Operation of protection zones. When a fault occurs within a zone, the relay detects that fault and the signal passes on to the circuit breaker. The corresponding circuit breaker trips the circuit, that means disconnect the circuit. Only faulty section is disconnected. The other healthy sections are remain unaffected. This ensures minimum disturbance to the power system and fast fault clearance. Typical protection zones. The common protection zones in a power system include generators, LT switchgear, that means low tension switchgear, transformers, HT switchgear, that means high tension switchgear, transmission lines. Each of these components requires separate protection because their fault levels and operating conditions are different. Zone boundaries and overlapping. Protection zones boundaries are decided by the location of current transformers. Zones are usually overlapped so that no part of the system remains unprotected. There are no blind zones, so system safety and reliability are improved. So overlapping ensures complete protection coverage. Conclusion on protective relay, it plays a vital role in a power system safety. It ensures fast fault detection, selective isolation of faulty parts, a reliable and stable operation of the power system. So proper zoning improves continuity of supply and system security. These are the diagram of protection zones. So the components generator, transmission lines, then transformers are connected. These are established, separated by the zones by using relays and circuit breakers. Then power system earthing. Earthing is the process of connecting electrical system parts to the ground. It provides a low resistance path for fault current. And it ensures the safety of human beings and equipment. Why we are needing for earthing? Earthing is required to protect people from electric shock, then prevent damage to electrical equipments, and it ensures correct operation of protective devices. Then maintain system voltage stability during faults. Then what are the objectives of earthing? The main objectives are safety of personnel, protection of equipment, limitation of over voltages, quick clearance of earth falls. Then what are the methods of mutual earthing? And the different methods of mutual earthing are used depending on system requirements. First one, solid earthing, resistance earthing, reactance earthing, Peterson coil or arc suppression coil earthing. Now we are going to see the solid earthing. In solid earthing, the neutral is directly connected to the earth. It is simple and economical. but high fault current flows, which may cause equipment damage. Next, resistance earthing. Resistance earthing. In resistance earthing, a resistor is connected between neutral and earth. This limits the earth fault current and it reduces the damage to equipment. Then reactance earthing. In reactance earthing, on inductor, that means a reactance is connected between neutral and earth. It limits the earth fault current using inductive reactance, that means XL, and is commonly used in medium and high voltage systems. Then Peterson coil or arc suppression coil grounding. Peterson coil grounding is a special type of reactance grounding. Uh, Here we are used a tunable inductor is connected between neutral and earth uh, to cancel the capacitive earth fault current. So this suppresses the arcing ground force and it improves system stability reliability, especially in overhead distribution systems. Overall, I explain how protective laying and everything together ensure the safety of personnel, protection of equipment, and reliable and stable of power system operation. And what are the methods of earthing? Thank you.